Hello, Math 3 students. Today we're starting our geometry unit, 5.1, any way you slice it. And we are looking at cross sections of three-dimensional shapes. I'll go into cross section a little later, but please use my lesson notes. There's a lot of good vocabulary words on there that'll hopefully refresh your memory on geometry. So Miss Denton's class, we're given cubes and made clay and asked to slice the cube with a piece of dental floss. Let's say the corner. So we have Jamal here who sliced it like so, and Jabari sliced it like so. So which do you think is correct? I'm going to have you answer on your own. But keep in mind, what does corner mean in math? Hint, there's no formal math definition for corner. Okay. So in describing three-dimensional objects like cubes, prisms, pyramids, we like to use vertex, edge, face to describe. So Jamal cut the vertex, while Jabari cut a face or an edge. Both technically included corners of the cube. All right. And we use to avoid corner or side. A cross section is a face formed by a three-dimensional object by a plane. It can also be thought of as the intersection of the solid. So a cross section is a face formed by a three-dimensional object sliced by a plane. It can also be thought of as an intersection of a plane or solid. So if you think about our globe, we call the lines of latitude cross sections. The lines of longitude are also cross sections. Or a basketball, this may look like more like a basketball, the cross sections are the laces, right? Those are cross sections. So draw and describe the cross section slope. So we show we're zooming in there, and to me that looks like this shape, three edges, so we're going to call this a triangle. Depends on exact measurements. If we have equilateral, isosceles, or scaling. Okay. Now we're going to look at Jabari's. Jabari's to here looks to me almost like a rectangle. So to me that looks like boom, 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 boom. We're going to call it a parallelogram or quadrilateral. And just like the above one with Jamal, it depends on exact measurement. To be parallelogram, rectangle, trapezoid, or even a square. Or even a square. Okay. And then they want us to draw more cross sections. So if you turn the page over, there's more cubes. So again, I can just cut. I can go straight down. If I go straight down, I create a cross section like so. Or top to bottom, sorry. Top to bottom. I could go across. I could even go diagonal if I wanted to. So let's go from here to there, here to there. Right? We can make all these cross sections depending on how we place our knife. We get cross section accordingly. Sorry if you missed that. I would from this side to this side. You can just draw any three you want, as long as they slice the cube with really any way you want to. You can slice the cube, right? So what type of quadrilateral is formed at the intersection of the planes through the diagonals opposite edges? So we have a line here, a line here. These are like opposite and parallel to each other. Then you have these lines here, which also are opposite, congruent, and parallel to each other. So if opposite sides are parallel and congruent, this would be a rectangle. Because opposite sides of the cross-sectional are parallel and congruent. Okay. Cross-sections can be visualized in different ways. So for instance, they did it with a dental floss and clay. Another one might be fill up a jug of water, right? And I can move this water around. Let's see, you have this water, right? There's a cross-sectional there, and so forth. It'd be easier to see in person, but you could have a water jug, put some water in it, move it around, and you have a cross-section with water. So 6 wants us to do that, draw cross-sections formed. So if I have a jar is circular. The water could either be cut down the middle in parallel, or, so this is parallel cut from bottom, and this will create a circle, or any other cut, like so, would be an ellipse. So any other cut would be an ellipse. Okay. Now we're going to do this with a cube. So if I have a cube, pretend all these are equal. So cube, all sides are congruent. I could go straight down the middle for a square, so that'd be yes. A rhombus, I could go diagonal. I could do a rhombus, I could do a rectangle, I could do a parallelogram, we could do trapezoid, we could cut off the corner and just do a triangle. Pentagon, I could hit 5 sides, 1, 2, 3, 4, 5. So yes, and hexagon I hit all 6 sides, so yes. The only ones I can't do is an octagon and a circle, because basically the max we could do is how many sides on object. And a cube has 6 sides, or faces on object. Sorry, we call them the faces. And we only have 6 faces, so the max I could do is a hexagon. Alright, so that is our mini lesson on cross sections. For the second part of this lesson, you could either do the ready, set, go, or you could do 2 IXL links, up to you for those second option. Alright, thank you for listening.